So this project basically consists of a PMOD keypad and a PMOD OLED which is already built on board. So I will start explaining the code. I'll start giving a brief explanation of this code. So this is the top module of this project. So we have the instantiation of the JA. This is the in-out for the OLED, for the keypad, and then we have a reset, and then we have the 4 buttons which are used for as an input. For the OLED we have output because all pins are output. We're also using the LEDs, so we'll use 7 outputs for that. I'm defining the wires that would be used for the various modules which we will be instantiating. So the first major module that we have is the decoder module, which takes in the input as the clock, the pins for the row, the pins for the columns, and then it gives an output of decode out. And we've also used key press just to detect when the key is pressed. So we'll open that and I'll give you a brief explanation of that. So this is the decoder module. So all the inputs that I just mentioned are given as an input, and this decoder is responsible for detecting which key is pressed in the keypad. So there's an always block which runs at the clock, which is the input, and we give a value of column which is assumed, and once the column value is selected, then we find the row as the input. So in this, clearly the in-out, because in-out is both input and output, the row values are the input to this module. However, the column value are an output to the keypad module. So we give column a value as an output for this, and then we detect what row was the value that we are getting over here, and based on that we'll decide what the decoder output is. So this would be on the given on the website which of the keypad. You could look at the description, and yeah, so that is mentioned over there. And so basically, if the column is 0 1 1 1 and the row is 0 1 1 1, then that would mean that the decoder output is 1. Similarly, if the column is 0 1 1 1 and the row is 1 0 0 1 0 1 1, that would mean that the decoder output is 4 or 0 1 0 0. So like that, if we do it for alternative columns, like first for column 0 0 0 1 1 and then 1 0 1 1, we are giving a time of lag which is approximately 10 nanosecond 10 or 100 nanoseconds, and we give that time for every column. Like that, we go one by one to every column, and one complete scan is completed, which gives the final output of decoder output whichever button is pressed. And then we go to the state machine, which has input as clock, and the decoder input, the decoder output that we have is given as an input to the state machine. We have 2 operands and 1 operator. So these 6 digits belong to the 2 operands. The first operand belongs to digit 1 2 3, and then 4 5 6 are for operand 2. Then we have operations. This is the last bit that is acquired from the decoder. So the decoder works the state machine also works on the clock, that when the previous key pressed is not equal to the current key pressed, then we are setting the operator 1's MSB as the first digit. Then the operator 1's second digit is set as iKeypad digit. Then the third digit of the operand 1 is set as iKeypad digit. Similarly, that is done for operand 2, and finally the operator. So the operator is the last key that is sent. So after this, we have this state machine then gives an output which is the operator operand 1, operand 2, and then the operator. Using that, we have the calculator. Calculator takes in both the operands and the operator as the input, and before that we had to convert the value from BCD to binary. So we have a separate module for that, for both the different operands. Both the operands are sent to BCD to binary module, and after that it is sent into this calculator file. The calculator takes in binary values because the calculation cannot be done on BCD, so we convert it to binary, and then the binary is being added, subtracted, or multiply and divide. And after we get an output which is in binary, we need to again convert it back to BCD. So we have another module called binary to BCD module, and this is then used to convert a binary value to BCD. The BCD value is then sent to this output display module, which has display operands. So each of these the parameters represents an ASCII character. So the BCD values that we have just received are again sent here, and then there's a corresponding ASCII value for each of those, and this would give an output of an ASCII value, which would then be used for the final display operation. So the final display is done using the result display.v. Yeah, so this is the final display operation. The first two operands, the operator, and the final result all are displayed using this final display module. Now I'll give you a live demonstration of this project. Okay. Give input. Operator 1. Give 2, 3. Operator 2. One more.